Time is money. That's especially true for today's farmers. When haying operations are shut down because of a twine knotter failure, time is of the essence. Although this scene may be familiar to you, it may not be as big of a problem as you think. If you'll just stop for a moment and examine the failed knot, you'll probably have all of the clues you'll need to diagnose and repair the problem, usually right there in the field. This program will help you learn to use your operator's manual in the field to quickly determine the cause of your knotter problems and get you back to your haying. Your OM illustrates the most common problems you may have, along with the symptoms to watch for and the solutions to the problem in the troubleshooting section. All necessary adjustments are also detailed in the Servicing the Baler section. A good starting point in the process is to familiarize yourself with the main parts of the knotter assembly. The knotter is made up of the intermittent gear, knotter frame, bill hook, twine disc, twine holder, twine disc cleaner, wiper arm with knife and wiper edge, twine needle, and the tucker finger. Now, let's look at each of the parts a little more closely. First, there's the intermittent gear. The intermittent gear is keyed to the needle lift shaft. It has two sections of intermittent teeth. One drives the twine disc pinion, and the other drives the bill hook pinion. An internal cam surface drives the wiper arm. There is another cam bolted to the side of one of the intermittent gears, which drives the tucker fingers. The next component you should be familiar with is the knotter frame, which holds the other components in their proper places relative to the intermittent gear and needle. The bill hook is what actually forms the knot. It is made of the bill hook tongue, and tongue roller. The tongue tension device, with the help of a spring, maintains the proper tension to retain the ends of the twine. The bill hook tongue cam opens the tongue. The cam is a replaceable part of the knotter frame. There are two styles of bill hooks, multi-twine and sisal twine. The multi-twine bill hook works equally well with sisal or plastic twines and comes standard on all balers. The sisal twine bill hook is only for heavy sisal twine. This bill hook is available from Service Parts. Notice the difference in the space between the bill hook and the tongue in the two styles. The multi-twine bill hook has a much narrower space to handle the thinner plastic twines. Plastic twine is smaller in diameter than sisal twine of the same tensile strength. The sisal twine bill hook will not retain the cut twine ends when using some plastic twine. This results in missed knots, loose knots, or knots with very short ends which pull out when the bale is handled. You must make several adjustments when changing bill hooks. Failure to make these adjustments will result in improperly tied knots. The first adjustment is timing of the twine disc. The twine disc properly positions the twine across the bill hook. It also holds the bale twine ready for the next bale. The correct position is determined by the relationship of the twine disc port to the twine disc holder. The twine disc is driven by the intermittent gear through a pinion and to an intermediate shaft with a worm. The worm gear drives the twine disc pinion. This adjustment is made by loosening the worm gear from the tapered shaft, repositioning the twine disc and worm, and retightening the nut. Be very careful not to over-tighten the nut, which may cause the worm gear to split or crack. The intermediate shaft must have some slight end play to allow the worm gear to seat on the tapered shaft. A good test to use is to check the washers. If they can be turned, the end play is sufficient. The wiper arm must also be checked for proper adjustment. All of these adjustments, along with their proper specifications, are listed in your operator's manual. The twine holder device applies tension to the twine. It must hold the twine as the bale is formed, but it also must allow a small amount of slip as the knot is formed. The twine disc cleaners remove the small piece of twine that is left on the disc after a tying cycle. The wiper arm and knife is driven by a roller riding on the internal cam surfaces of the intermittent gear. The throat of the wiper arm positions both the bale twine and the needle twine across the billhook. The replaceable knife cuts the twine so the loop of the knot can be wiped over the tails. An adjustable wiper edge wipes the knot from the billhook. Next is the twine needle. The twine needle takes the twine from the twine disc around the bale and back to the twine disc. The needle must make light contact with the knotter frame to properly position the twine as it enters the twine disc port. The guide in the tip of the needle is not intended to roll. The final component we'll look at in detail are the tucker fingers. The tucker finger places the needle twine into the throat of the wiper arm and across the billhook. The actual tying operation is completed in less than 1 second. Since the whole process happens so quickly, we'll take a look at the various stages of the tying cycle. The twine holder secures the twine in the twine disc. The twine is over the tongue of the billhook and through the throat of the wiper arm. This is the bale twine. As the bale forms, it pulls twine from the twine box. When the bale reaches the proper length, the measuring wheel trips the knotter mechanism. The needle, with the aid of the tucker finger, brings the second strand of twine through the throat of the wiper arm, across the billhook tongue, and into the twine disc port. This is the needle twine. Next, the first set of gear teeth on the intermittent gear engage the twine disc pinion gear, which turns the twine disc to securely hold both strands of twine. Once both ends of the twine are secure, the second set of teeth on the intermittent gear engage the billhook pinion. This turns the billhook so it forms a loop of twine around the billhook. The roller on the tongue mechanism contacts the cam, a separate piece in the knotter frame, to open the billhook tongue. At this point, the needle recedes, leaving the twine in the twine disc. This twine will become the bale twine for the next knot. The billhook tongue then closes to hold the ends of the twine. Next, as the wiper arm starts to move, the knife cuts the twine, and the wiper edge wipes the looped twine from the billhook. The tongue holds the ends and the knot is formed and drops from the billhook. The needle returns to home position and waits for the next tying cycle. Let's watch another tying cycle so you get an idea of just how fast all these steps are completed. We'll take a few minutes to look at some of the more common problems you may have in the field and what you can do to get your baler up and running again quickly. Remember, all of these adjustments are detailed in your operator's manual. Never hand trip an unthreaded baler running at normal operating speed. If the knotter mechanism is tripped without twine in the twine disc, the billhook tongue will open and remain open until the twine is properly threaded. As the billhook rotates with the tongue in the open position, the tongue may be damaged as it strikes the tension arm. The pressure of the twine in a properly threaded knotter closes the tongue to prevent the damage. There are 2 areas of the knotter where twine tension can be adjusted. Correct adjustment is critical to proper knotter operation. The first area is at the twine box. The tension must be measured with the needle at the knotter. Incorrect tension here may result in knotter malfunction. The second critical tension area is the twine holder tension at the knotter. Incorrect tension adjustment may result in twine breakage, premature knotter wear, or pullout. Regardless of how your baler is equipped, a good understanding of knotter functions and adjustments is essential to reliable operation. While watching the operation of the knotter may be interesting, it operates too quickly to solve problems merely by observing its operation. You must diagnose the tying problem on the broken bale before making any adjustments to the knotter. Failure to do this may cause you to introduce new problems and complicate what should have been a simple field repair. Before you get angry and rebale a broken bale, take a moment to look at the twine and figure out why the bale is broken. By comparing your broken twine with the examples given in the troubleshooting section of your operator's manual, you should be able to quickly diagnose and repair most knotter problems. You need to be able to determine which end of the twine is the bale twine and which is the needle twine. This is actually pretty easy. First, determine which side of the bale is the cut side, as opposed to the chamber or smooth side. With the cut side toward you, the knot should be at the top near the right end. The vertical twine closest to the knot is the needle twine. Likewise, the horizontal twine closest to the knot is the bale twine. The most common knot failure is at the base of the knot. This is usually caused by exceeding the knot strength of the twine. The knot strength of quality twine is usually listed on the label. It is about 1/2 of the tensile strength of the twine. This strength and the quality of the twine will be major factors in determining how heavy your bales can be. One way to avoid strength-related problems is to always use fresh sisal twine. Sisal twine will deteriorate, especially if stored incorrectly. If you experience knot breakage at the base, you have two options available to solve the problem. The first and easiest is to reduce bale density. The other is to buy a twine with a higher knot strength. It's a good idea to do your own knot strength tests if the problem persists. It's actually quite simple. All you need is a spring scale, a portable hand winch, and 2 anchor points. Test a minimum of 10 knots for accuracy, and you may find it helpful to compare hand-tied knots with machine-tied knots. The knots should fail close to the listed knot strength, and always at the base of the knot. Another possible cause of failure at the base of the knot is incorrect stripping of the knot from the bill hook, caused by incorrect adjustment of the wiper edge to the bill hook. Always check the specifications given in the operator's manual. You can easily check this by stopping the baler and examining a knot for damage before it has had tension applied by the bale. If there's no damage to the twine at this point, the problem is due to twine quality rather than the knotter. If when checking the broken twine, you find a failure with the knot in the needle twine, but no knot in the bale twine, the problem is usually caused by a twine disc pullout. This is caused by either too little tension at the twine disc or excessive pull caused by the crop material. Increasing the twine disc tension will usually solve the problem. Be careful, though, not to set the tension too high, or the twine may be sheared in the disc during knot formation. Reducing the bale density may be necessary if the twine disc adjustment does not solve the problem. If you find a failure with the knot in the bale twine, but none in the needle twine, this is caused by a condition called tucker finger miss. This is usually caused by crop material holding the twine out of position for the tucker fingers. This may be caused by misadjusted tucker fingers, hay dogs not working, plunger head mistiming, or on older balers, the plunger head extension should be put on. The extensions are usually needed in straw or other light, springy materials. On the newer balers, the plunger head extensions are standard equipment. See your operator's manual for proper servicing instructions. Before making any adjustments, be sure to disengage the PTO, turn off the tractor engine, and remove the ignition key. The baler must be stopped. If equipped with an ejector, it must be locked out. Never make any adjustments while the tractor or baler is running. John Deere balers are carefully designed and manufactured to include a heavy layer of grease on many of the knotter's parts. Some parts are highly polished to prevent cutting the twine. Even something as little as the paint wearing away can leave an edge sharp enough to cut twine. The polished parts should be greased liberally before storage or touch-up painting. Be sure to remove the grease prior to returning the baler to service. It's important that you thoroughly understand the instructions in the operator's manual to ensure that your baler will keep running efficiently. Each section of your manual is clearly identified so that you can easily find the information you need. Plus, your John Deere dealer is ready with a complete selection of parts and technical assistance for prompt, efficient service. Following the recommendations in your operator's manual will keep your baler in top condition for years of dependable service. Balers are built to handle a wide range of field conditions, which not only change from year to year, but also from hour to hour. A careful study of baler adjustments and what they accomplish under varying conditions allows you to maximize the performance of your baler. And when time is money, you can count on John Deere to help you make the most of your time.